So hello everybody, I'm Massimo Benini from CSCS. I am a software developer there. So this is the agenda for my speech. I will talk a little bit about our environment, our GPU allocation, the policy that we have about jobs, the user tools. Then I will show you the management GUI that we use to create project and manage the users and the quota. And then at the end, how can we collect data and create reports about all this data that we have. So this is a big overview. We have our facilities on the top, are mainly Craze facility. And they're all connected to a Slurm database daemon. This database daemons is shared between all these facilities, all this cluster, and it stays in a HA separate cluster. And in the underlay, it talks with the Slurm database. So in this database, we have all of the transactions about jobs that run on our system. There's a lot of communication between our CSCS company database and this database. We use LDAP for the users. We use Kerberos for the authentication service. So all of these items more or less are interconnected together, and there is a data flow between them. So in this presentation, I quickly try to present the interaction between all of these entities. So this is what we have to deal with in our CSCS database. We have physical persons. We have projects. Every project must be related to one physical person. In that case, it's the principal investigator. Then we have account. There's a one-to-one relationship between person and accounts, because one person can have multiple accounts. Of course, an account is related to our facility. And a quota, let's say for the moment that we have a quota, which is in CPU hours used for the facility. And a quota, it's a pair. It's related to an account and a facility. So we are giving a quota in CPU hours for accounts and facility. It's not CPU hours, but we'll see later. So common compute currency. Common compute currency is the new job allocation system, job accounting system, that we started at CSCS, I think 2 years ago. The key feature of this system is now we're giving a global quota to the project. And so with this global quota, the person can run in all the systems. But we want that the job priorities is influenced by the utilization of this global quota. And in all systems, but not in every system, we set anyway a local threshold for the facility. So we have a global quota and a local threshold, a local quota, let's say. The allocation lasts for 3 months. And then we want to have different type of quota for different projects. Can be contractual partner, production, pre-production, and development. See, this mechanism has been designed to give the project office more control about how the user run in the facility. So to implement this mechanism, we create a virtual facility called Global Quota. And we pass from CPU hours, our previous quota was charging CPU hours. Now we use what we call allocation units. Allocation units, it's CPU hours multiplied by a cluster factor. Cluster factor, it's this one, so it's a value for every cluster. At the beginning, we can charge differently based upon the number of CPU that you use, but as you can see, now we're not using this feature. And only on ROSA, one allocation unit is 1 CPU hours. Then we can go deep in the granularity. For instance, we can give different values, different cluster factor for a partition inside a partition, which is a queue inside the same cluster. Okay. So this table, it's in the CSCS database. So Slurms, our resource manager, store information in the Slurm database, store information about the number of CPU used by a job and the wall clock time. So we have CPU hours. This information, we copy this information in our CSCS database in a table called job accounting. To do this, we implemented this cron script cluster because run, for instance, there is ROSA accounting PL, TODI accounting PL, Dynta accounting PL. They run every 6 hours. It basically copies the information about the jobs that run in the previous 6 hours in the CSCS database. In this table, the data about jobs are stored with CPU hours. We don't do the conversion here. But there is a trigger, a MySQL trigger, that when you write an entry here, it automatically go and change another table called CPU usage count. And here we have the conversion. We multiply the CPU hours per the cluster factor. And the data here are in a form cluster, project, CPU hour, allocation unit used. So we have the other way around. So we have to move data from CSCS database to the Slurm database. This is because when we create an account, a quota, organization project, all of this information are stored here. But because with Slurm we enable the accounting, we need to move this information even here. So every time we add a user, it has to go in the Slurm database. This is why we implemented this script. Use SQL queries to get this script. Use SQL queries to get the data from here, and this command, which is a Slurm command, to move the data here. Run roughly every 30 minutes on each system, which is we thought it was a good time. So jobs priorities. How can we manage the job priorities in our cluster? We favor large job instead of small job. So because we try to always keep the machine full as possible. We use this plugin, Slurm plugin, is called Multifactor, which gives us a fair share, because otherwise Slurm comes with a first in, first output queue. This is the formula for the priority, to calculate the priority. Higher this number, lower is the priority. So, for instance, it takes into account the age of the job in the queue. Fair share, we disable this, so we put at 0 on the on this factor, the job size, so the number of node that you want to use, and we use the partition. We don't use quality of service here. Quota consumption, but this is not enough for us because we want to take into account even how much global quota the group has used, and how much local quota if you're running in a cluster with a threshold. So we create this other script. This other script take into consideration all these aspects: the project type, the global quota use, local quota use, and then the time left to the end of the allocation period. This script generates a simple flat file with the group ID, the project, and the priority. How can we integrate this with the multi-factor plugin? We use this hook on the Slurm side. So every time we submit a job, we take the multi-factor priority, and then we go to add the group priority, which is present in this file. So we have a real job priority. In a cluster like Rosa and Todi, Dint, I don't know, because at the moment it's shut down, but I don't know in the future, we use this bottom feeding. This bottom feeding mechanism is a mechanism where if you're over quota, you're allowed to run any way, but you'll be bottom feeding, so you will reach a very high priority. You will run if nobody else with a higher priority than you want to run. So to give to the user a sort of mechanism where they can check their quota, we develop mainly a couple of commands. hpc-ch is the most used command. Then monthly usage that tell you how much allocation unit you've used. And then you have all these sets of commands that comes with Slurm. Here a quick example of hpc-ch. This user here, Ruben, he has 3 accounts. This is the allocation. This is the local quota on Rosa. This is the global allocation. And when you submit a job, you can choose with Slurm which project, which group you want to use. And not many users know, but even in our user portal, if you log in, you can check your allocation quotas. Okay. So management guy. One of my first tasks at CSCS was to re-engineer the program where to insert account, project, and users on the CSCS database. Because before they were a standalone Java application. Because I came from the web application world, so I thought it was good to create a web application. I use these common tools, and I create this which is an interface to the main database, CSCS database. And with this database, with this guy, we have to introduce the new feature that comes with the new compute currency accounting program. So this is the main the home of the web application. You can see you can deal with project, person, accounts. Here you can set the quota. This is still have to be finished. And here you can set the cluster weight. This is an example of inserting a new project. As I said before, you have to make sure to have a principal investigation, which is the reference person for the project. Here, how you can update an account. For every account, you have a list of the facility related to the account with the expiration date. And then this is my last slide. So we have at the moment 40 million of entry in the Slurm database, and there are all transactional data. So we thought about to create a business intelligence platform to go from transactional data to OLAP cubes, which are online analytic processing data, in order to create a report and analyze how the user utilize our cluster. For instance, create reports about the job size, job utilization. In the future, we can add power consumption if we get the data, and we are working on it at the moment. So this is more or less what I have. So if you have questions.